This video is about solving linear systems using substitution. I've chosen two examples. In the first example, one of the variables is almost by itself. This x in the bottom equation, I'm solving for x that equals 11 minus 5y. I put that in for x in the top equation, and now I need to solve for y. So I distribute, and I combine the like terms, and I find out that y equals 2. Now I take that 2 and I plug it into one of the equations. I chose the bottom equation because it looked simpler. And I can find out that x plus 5 times 2 equals 11. And that gives me the value of x. X equals 1. So my solution is 1, 2. I should check my work by putting 1, 2 into the original equations. In the first equation, 8x plus 8y equals 24. I put in 1 for x and 2 for y. Do I get a true equation, I'm asking? Yes. In the second equation, it's x plus 5y equals 11. And when I put in 1 for x and 2 for y, I get a true equation. So that's the solution. My second example is a little more complicated because it's a little more work to solve for one of the variables. I'm choosing to solve for the x in the bottom equation. So 2x equals negative 4 minus 3y. And that expression for x, I can put into the top equation in place of x. So I write 4 times negative 2 minus 3 halves y minus 3y equals 28. Now I distribute and combine like terms and solve for y. So in this problem, we see that y equals negative 4. I use that result, y equals negative 4. I plug it into one of the two original equations. I chose the bottom one. And that'll let me solve for x. 2x equals 8, so x equals 4. So my solution is 4 for x and negative 4 for y. Again, I check my solution by plugging in 4, negative 4 in place of x and y in the two original equations. So the top equation is correct, and the bottom equation, if I put in 4, negative 4, that gives me an equation that's also correct. So those are my solutions. That's how we'd use substitution.